Hi everyone, this video is going to be all about the atomic model that was developed by John Dalton back in the 1800s. This is really the first atomic model that we face this unit, and John Dalton was a scientist who made a couple of claims about how he thought the atom itself behaved. His first claim was that atoms are indivisible spheres that make up everything. And when he said indivisible, he means can't be divided, so we can't break them down into smaller pieces. This idea actually wasn't new. Back in the BC era, a philosopher by the name of Democritus also had this idea. In fact, that's where the word atom comes from, is from the Greek atomos, which I believe means indivisible, but honestly not 100% sure. This essentially was a borrowed idea that had been disregarded for centuries upon centuries until John Dalton brought it back to the forefront of chemists' minds. So his first tenet, atoms are indivisible spheres that make up everything. He went on to say that atoms of the same element are the same. So what he meant was that every single atom of oxygen looks and acts exactly the same way. We knew about elements. We just didn't really know how they were made or what they looked like on an atomic level. And the same element are the same. So this was a bold claim, and we'll sort of look and see over time how that claim has been refined and adjusted. His last claim really started to get at this idea that maybe we have more than just elements here on Earth. Maybe there's another type of pure substance that we today know of as compounds. And it was Dalton that first proposed this idea that atoms can link together in fixed ratios or proportions to form compounds. And this indeed is the Regents Chem definition of compound: two or more different elements linked together chemically in a fixed proportion. So it was Dalton that first kind of proposed this idea. That said, he had absolutely no idea how that process would take place, because his idea of what the atom itself might look like was just a big indivisible sphere. So if I was going to draw his model, I would draw something like this, where nothing comes in, nothing goes out. It's the smallest piece of matter. It's indivisible. And somehow, some way, we can link atoms together to form new compounds. So its main use is in drawing particle diagrams, right? When we started at the beginning of the year drawing particle diagrams of substances, we were really using John Dalton's methodology. And he said that, okay, if I want to draw H2O, all of my H's should look the same, and they should look different than O's. So if I were to draw H2O, I can use these spheres to represent the individual atoms, and atoms of the same element will be exactly the same, and they'll be different or unique from other elements. And that's really about as far as we can push John Dalton's model, because we need to start knowing more about the inner workings of the atom if we want to take things any further scientifically.